Let's see. Oops, went too far already. There we go. Thank you all for coming here and being at the Future Mars Exploration Town Hall today. We're really happy to have you all here. We're really happy to be able to talk with you guys about a number of different things. As Charles introduced at the NASA Night Town Hall on Monday, the reason that we're having a separate Mars Town Hall is because we wanted to be able to share some sort of big updates to Mars planning that have come out really recently. Within SMD, of course, we have the Mars Exploration Program Future Plan that was published just this fall. We have the Mars Sample Return Mission Design Go Forward Plan that also came out early this calendar year. And then we're also going to be able to hear today a little bit about the Exploration Systems Development Mission Directorate plans for future Mars exploration. So there's a lot of more detailed information about Mars exploration that we want to be able to share with you. And so I wanted to take a minute to introduce who will be talking to you all today. I have on stage with me Tiffany Morgan, who is the program director for the Mars Exploration Program, Danya Douglas Bradshaw, who is the program director for the Mars Sample Return Program, myself, who is a senior scientist for Mars Exploration, or the Mars Chief Scientist, somewhat colloquially known. And all three of us are actually new to these roles within the past year, so we're really excited to be able to sort of introduce ourselves to you all, as well as to talk about a number of things. And then finally, we also have Jake Bleacher, who will be joining us again remotely. And the fantastic folks who are organizing and doing the tech here have assured us that this is going to work really well today. So I'm really excited about that. Really excited to have Jake with us as well. Before we go into details or we have any conversations, I wanted to start by making this note, and note that this applies to what we are talking about today. The agency is currently operating under a continuing resolution for fiscal year 25, and the FY26 President's budget request has not been released. So in that context, keep that in mind as we're talking to you about what we're going to be planning today. So I wanted to start by talking about and sort of setting the stage for thinking about future Mars exploration by starting with this slide, which I am sure many of those folks in this room and perhaps in some of the other waterways and online are very familiar with what's on this slide, perhaps some of these missions more so than others. But this slide really shows, goes all the way back to our current oldest operating Mars mission, Mars Odyssey from 2001. And it shows, the missions that the NASA and our NASA partners have had since then, as well as the planned missions that we're looking at going forward. And I want to say this because the future planning for Mars exploration is part of, our history of exploration of Mars. And the things that we are thinking about, the things we are planning, the things we are talking about today build on the context of all of these missions that have come in the past. So really, we're thinking about the future, but we're also, there's been some fantastic sessions today and in the next, and the past couple of days and in the next couple of days about the data from some of these missions and thinking about some of these future missions. And so I want to, sort of put all of that in the context of, this Mars exploration program that we have had. And then when we talk about the Mars Sample Return Campaign, I really wanted to take the opportunity as well to sort of set the stage there and to sort of remind folks of the difference between the Mars Sample Return Campaign, which is all three pieces that you see here. So the Mars 2020, the rover that is operating on the surface of Mars, collecting samples, doing analyses to put those samples in the context of the environment there. The Mars Sample Return Program, as well as the sample receiving project. So the Mars Sample Return Campaign is everything from when the samples are collected through that initial science. And that whole thing all together is the Mars Sample Return Campaign. Now, the first and the third elements that you see on the slide here are part of the Mars Exploration Program. So these are the parts that have the large science teams that are really sort of thinking, or will have the large science teams that are thinking about the science of these samples. Whereas the Mars Sample Return Program is the piece in the middle, right? This is a predominantly engineering-focused program. And what it is it's looking to accomplish all of these engineering feats, all of these engineering firsts, in service of getting the samples from Mars back here to Earth. And when we think about the science there, sample integrity is really the key part of the science of the Mars Sample Return Program. So I just want, as you know, as we throw the words about Mars Sample Return Campaign versus Mars Sample Return Program, I just wanted to remind folks of where those two things are and how they sit and how they fit relative to each other. So that is my last slide, and I'm going to hand it over to Tiffany to give you a little bit of information, or a good amount of information, about the Mars Exploration Program.
Okay. Thank you. Good afternoon, LPSC, and thank you, Lindsay. I am very thankful to have the opportunity to talk to you today about the Mars Future Plan, expanding the horizons of Mars science. But before I go into that, I want to talk a little bit about the year that we've had and some of the accomplishments that we've made and some of the changes. And so while I am new to this position, I am not new to the program. I have been Deputy Director of the Mars Exploration Program under Eric Ianson for the last 3.5 years. And again, I'm very thankful to be up here to share what we've been accomplishing. Some other changes that we've experienced in the last year is we've said goodbye to a handful of folks that have really enabled science on Mars and the missions to Mars and new discoveries over the last 20 years. We had 2 program executives, Ramon DePaula and Dave Lavery, who have just had phenomenal careers helping Mars and helping the Mars Society. They retired, the Mars community. They retired at the end of last year. In addition to Eric Ianson, who departed at the end of last year. But before he did that, he and Becky McCulley-Wrench were able to release the official Mars Future Plan, expanding. Oh, I forgot to. Sorry. I'm just a meatball. All right. So expanding the horizons of Mars science for us. And so hopefully many of you saw that presentation at AGU last December. So our program of record within the Mars Exploration Program is currently 5 assets. We've got 3 orbiters and 2 rovers. Odyssey has had an amazing year. In fact, at the Monday town hall, there was a picture of Olympus Mons at the bottom of Charles' slide, and that was taken by Odyssey's Themis. Odyssey also had its 100,000th orbit anniversary last June. It's been orbiting around Mars longer than any other satellite actively orbiting a planet except Earth, around Earth. So 23 years in orbit since Mars Odyssey 2001. Congratulations, Odyssey. And then 2 other big anniversaries. Maven in September of last year had its 10-year anniversary orbiting Mars. And MRO coming up in September of this year will have its 20th anniversary for launching. So thank you to Maven and MRO as well for all the wonderful science they've brought to us. So these 3 satellites, along with ESA's Trace Gas Orbiter and Mars Express, make up our Mars Relay Network. And note that Trace Gas Orbiter is the newest of those, but the newest of the orbiters for NASA is Maven, which launched in 2013. I'll talk a little bit more about that later. And they help ensure that we can get data back from our rovers, Curiosity and Perseverance. Curiosity has been roving since 2011, 12, launched 11, 12, oh. 42 samples drilled and just reached 34 kilometers on a Gale crater this last year, and then or in 24. And then in 25 this year, Perseverance surpassed Curiosity, and they're now at 35 kilometers in roving around Jezero crater. And they are also collecting samples, as many of you know, and I'm sure going to ask a lot of questions about that today. But we've got 18 rock cores on board of Perseverance, 7 rock cores at the Three Forks cache, and we still have 8 sample tubes left to fill on Perseverance. That's not counting witness tubes and some atmospheric and regolith samples. Right now, we're planning to bring those Perseverance samples back to Earth in the 2030s. You'll hear a lot more from Danya about that. But before we can bring them back, we need to have a facility that is ready to contain and to protect those samples from contamination. And we're going to do that through the sample receiving project. The sample receiving project is going to retrieve the samples from the Utah Test and Training Range, which is the same place that the OREC samples came back to. They're going to contain the samples. They're going to curate the samples, do some basic characterization, and then sample safety assessment before we release those samples to the world at world-class laboratories for new discoveries as soon as possible. What you see here on this chart are the sample tubes up here in the top right. And then we've also got some handling, robotic handling equipment down here in the bottom right. You can see X-ray tomography of an actual analog sample tube up there in the left. And then we have the double-walled isolator, which is enabling us to maybe reduce the amount of requirements that are happening in the sample receiving facility by doing it in this double-walled isolator that ESA is working to develop as part of this partnership. This last year, the team has been working really hard on sample safety assessment protocol definition. They've been working with experts to get that policy, and I believe we've got some publications coming out in the next year or so, as well as standing up a measurement definition team to go through the workflows and understand what we need to do for both science and for sample safety assessment. That information that the team has been collecting will inform the future facility concept and the design for where we'll house those samples when they return. Another effort that is ongoing is the ESA's Rosalind Franklin mission. NASA's contributions are known as ROSA, which is Rosalind Franklin Rover Support and Augmentation. You can see a picture of Rosalind Franklin rover here as well, and our contributions are this mass spectrometer to the MoMA instrument, which is the primary instrument on ROSA to try to identify biosignatures of past and present life. RFM has a drill that goes 2 meters below the Mars surface to get those samples that have been protected from radiation. So it's a very important contribution. We're also doing the radioisotope heater units for when the rover is on the surface of Mars, as well as the entry and descent landing engines, a launch service, and systems engineering support for RFM. Or Rosalind Franklin mission. This past year, they successfully completed their PDR, and they are going to, or their preliminary design review, and they are going to get confirmed through key decision point C this May. So on to expanding the horizons of Mars science. The headquarters and JPL teams have been working, Mars teams have been working on this product for about 2 years now. We've had a whole bunch of activities in parallel with this, but we also had a lot of inputs from the community, from the science community, from industry. We looked at the decadal, we've looked at a whole bunch of other studies that have been done by the community to develop this product. It is available online in detailed format. As I said before, Eric and Becky McCauley-Wrench formally released this at AGU. The reason that this is so important now is threefold. One, there's more interest in going to Mars now than ever before, whether it's robotically or humans going to Mars. We've never had this much interest in physically going to Mars as we do now. Two is our assets are aging. I mentioned before that MAVEN was our last comm asset that was launched to Mars on MRO. We have HiRISE, which was launched in 2005, which is imaging and does target imaging for landing site surveys. Those are very important infrastructure items that we need to renew at Mars. And then third is over the last decade, industry and commercial and international capabilities have grown extraordinarily. And we would like to partner to make sure that we can take advantage of all those capabilities that have been developed going around Earth and going around the solar system by industry and those partners for the last decade. Our goals with this plan are also threefold. The primary goal is obviously to get more science, decadal level, high value science for the community, but we wanted a sustainable program with a level, predictable, flexible, scalable budget that could be manipulated in an interesting environment, in an interestingly fiscal environment. We also want to enable lower cost missions. And like I've said before, we want to replenish that infrastructure. We have 3 science priorities for the next 2 decades with this future plan. The first is exploring the potential for Martian life. Is there life or was there life on Mars? Does it tell us anything about the origins of life on Earth? We also have revealing Mars as a dynamic planetary system. We'd like to understand how Mars is changing today through atmospheric and geologic sciences and see what that can also tell us about Earth. And then finally, support human exploration of Mars. We released, or we asked the national academies to conduct a study on what science priorities would be the highest for human missions to Mars. But we don't understand, based on those priorities, do we need to do reconnaissance to enable those science missions? Do we need to inform policy for humans to go to Mars? Are there other safety factors? So preparing for science, preparing to support those human missions to Mars are important and part of this plan. One thing that this plan is not, that I want to clarify, is this is a plan that is for robotic science exploration of Mars. Jake will talk more about the architecture for human science missions to Mars. This is strictly robotic science missions to Mars. To achieve those 3 science priorities within the plan, we've outlined 4 initiatives. The first is the Explore initiative, and this is really what kind of missions are we going to send to Mars? And we've got 3 different classes for Explore. We have low-cost missions, 3 primary classes, low-cost missions, which would be, under, say, $500 million. And then we have medium class missions, which would be in the $1 to $2 billion range. And we have hosted payloads so that we can take advantage of our partners' launches as well as some of our own launches going that direction. The second initiative is infrastructure. In addition to communications and imagery at Mars, we also would like to have a Mars weather network that can tell us more about transport models and surface monitoring for future missions. We also need transport to get lower cost missions to orbit and to the surface of Mars. Those are considered part of our infrastructure initiative. The third initiative is technology. So this would be entry, descent, landing, and novel surface mobility to reach parts of Mars that we've never accessed before. We would also have data systems and data planning and sample handling and for in situ sampling and receiving. And the fourth initiative is really our cross-cutting initiative, togetherness, and this is partnerships. And we have partnerships in each of these areas, but to responsibly explore Mars with our partners so that we can include everyone in going to Mars. Progress. So there's 2 areas that we've made a lot of progress on in our Mars future plan. And the first is commercial services. So I want to explain what commercial services is first. Commercial service is when our industry partner owns and operates the asset and the government purchases services for whatever capability that is. And last year, we initiated a study with industry. We had a lot of phenomenal response from them, and we selected and awarded 12 studies to 9 different companies to study 4 different infrastructure areas for potential services. They worked under some design reference missions in terms of getting satellites to orbit around Mars, hosting payloads, delivering communications, and delivering imagery. We have been very happy with the results that we've had from this commercial services study and learning what we can from industry. It's been another point to illustrate just how far the growth of what industry and the community have accomplished over the last decade. We are still determining next steps and what we want to do with this information that we've gained, but we expect to have a public engagement within the next year, hopefully sooner than a year from now, but those are the next steps. And then the other area of progress has been in what are those science priorities to achieve before we go to Mars, before we send humans to Mars. So about a year and a half ago, Mars Exploration Program, the Planetary Protection Office at NASA, and the Mars Exploration Planetary Analysis Group got together and said, okay, humans are going. What is it that we want to do in advance of humans going? What are the priorities for us? And so we convened a group of experts to host some virtual workshop and seminar, which was held in summer and fall last year. And it was science and planetary protection in advance of humans going to the surface of Mars. And that report is coming out this April, so in just a few months. And I'm going to read to you some of the key draft findings. So monitor surface weather at Mars to better understand dust movement and weather patterns to inform transport models for forward planetary protection and contamination. Very important. Characterize landing sites to mitigate and control potential harmful contamination impacting future science, and develop advanced technologies. So these are the things that we're looking at in terms of what can we achieve with the construct that we've put together with the new future plan. And this, along with the commercial services, will result in a public engagement in the near future to talk about how we can maybe put some of these things together to come up with a plan to achieve these things. That is the end of my talk. Again, I want to thank you for the opportunity to talk about the Mars Future Plan and expanding horizons for Mars science. And I will turn it over to Danya now to talk about Mars sample return.
Thank you. Thank you, Tiffany, and thank you, Lindsay. It's a pleasure to be up here as an engineer and a project manager and not a scientist. And I don't play one on TV either. I have to say, being here this week in this space has been extremely inspirational and has reminded me of why I longed to work for NASA as a child. So I appreciate hearing the science. I can't say that I understood a lot of it. I appreciated the passion and I certainly appreciate all the hard work that you all have done. So I wanted to start off. So like Tiffany, I have been part of MSR. I've actually been in this role for, has it been 90 days yet? Maybe not 90 days, but I was the deputy program director under Jeff Gramlin for a year. And prior to that was the CCRS project manager. Have lots of experience at Goddard as a project manager and as an engineer, and I'll talk about that in the end. Just want to share some remarks. But I really wanted to start off, I mean, one of the things that I intentionally do when I join a new program or a new project is I'm very intentional in being quiet and just watching and learning from the scientists, learning from the engineers, learning from the project managers. I'm never one that is interested in coming in and disrupting things if it's working, right? And I must say, having been part of CCRS and having been part of MSR, working with this leadership team, I've learned a lot. And I just want to acknowledge them and give them their kudos for all of the effort that they've done to bring MSR to this point. And I do believe where we are now, we are well positioned to be successful in bringing those samples home. So I want to give them their flowers, right? They've done an outstanding job on a challenging mission. But I also want to acknowledge my leadership team. This is my senior leadership team. One of my mentors told me years ago to surround yourself with people that are smarter than you, if you want to be successful. And I will say that I've certainly done that. This is an awesome team. If you're not aware, the program office has moved to headquarters. And so over the last year or so, we've had to build up the staff, and we've been fortunate enough to bring on really exceptional people that have decades of experience that has enabled us, even in the midst of all of the challenges and the studies that were going on, to continue to make forward progress on MSR. This team is an outstanding team. I have the utmost confidence in them. As a matter of fact, this week, they're off leading. They're the ones that are closest to the projects. They're the ones that are actually leading the folks to actually accomplish this mission. So again, I want to acknowledge them and their contributions. And so in preparing for this, right, I think it's important to make sure that not only that you are heard, right? I want to make sure that I'm addressing what the community is interested in. And I know that there's been a lot of discussion around what the announcement and what the decision with respect to MSR was. And so that's the focus of my talk. So let's kind of step back for a second, right? I think folks are aware that we had an independent review board that provided their report in September of 2023. And then the agency established what they called the MERT, which was the MSR, Independent Review Board 2 Response Team, right? And so they went off and they were tasked with evaluating and looking at the findings from the IRB2 and developing responses and recommendations to make to the SMD Associate Administrator for her to make to the administrator. And there were some constraints that were put on that team. There was a significant interest and focus in making sure that we balance the science portfolio, and that continues to be a priority. But those constraints, those guardrails, yielded an outcome with regards to the recommendation. And out of that, it yielded a architecture that resulted in samples that would be returned in 2040. And time is money. So if it takes you longer to do it, it's going to cost you more money. And so the estimated cost of MSR was around 11 billion. And so that was briefed out to the administrator in April. And the administrator kind of said, not good enough, go back to the drawing board, right? I want the samples faster, and I want them for less than 11 billion. And so that allowed us to lift some of those constraints that the MERT was operating under. It also allowed us to go out to industry to see what novel ideas that were out there that perhaps hadn't been considered. And so out of that, we went out with a call, and we got about 48 responses from industry. So very high interest in that. And then there was a team that was put together to evaluate those 48 proposals to do a study or an architecture or any aspect of the architecture. And they were down selected to about 8. In addition to that, a NASA team was put together to also evaluate the MSR architecture for ideas. And then JPL did a study and Marshall did a study, and then as well as APL. So we ended up with 12 studies of the architecture, and they fell into these 3 categories. Of those 12, we had 6 that provided end-to-end mission architecture. We had 5 that proposed a smaller MAV, and within the mission architecture ones, they also, the majority of them, 5 of the 6 proposed a smaller MAV. And then we had one white paper, one study that proposed a cislunar return mission. And so what was exciting out of what came out of that was the MAV, the Mars Ascent Vehicle, is really the enabling system, if you will, for Mars sample return. And what we saw with those studies was that a smaller MAB was feasible and a smaller MAB was achievable. And that enabled us to have a smaller lander, less complex, less mass. You all are scientists, you know, mass also equates to cost, right? So it was really exciting. So out of that, what we saw in October when the MSR, an independent team of scientists and engineers and programmatic folks, was that there was a viable solution for us there was a viable architecture in which we could return samples as early as 2035 with a mission that was less than 11 billion. And so that's what you heard from the administrator. But even more exciting than that was also the recognition that what came out of the studies was a new potential opportunity and methodology for actually landing the payload on Mars. And so when the administrator talked about the dual path, what we're talking about is basically the methodology for landing the payload on Mars, whether or not it's the traditional approach that was used with Mars 2020, where you have a cruise stage and a descent vehicle and a, sky crane, or you have a heavy lander. But what you see before you are the elements of MSR that are common to both of those opportunities, those options. And what that allows us to do is maximize all of the engineering development that's been done over the last 4 years so that we have confidence that we'll be able to make our 2035 schedule. And I'm holding my project managers to that. I told them they have no more money and no more time. They need to meet their launch readiness dates. And so let's talk about what those elements look like. And so what you see, let's see. So we basically have 2 primary missions that are part of MSR, if you will. The first one is the sample retrieval, which lands the payload on Mars with the Mars Ascent Vehicle and the orbiting sample container, and then launches, or the launch vehicle launches off of Mars and places the OS in the Martian orbit for the Earth return orbiter with the CCRS, the catcher's mitt, to actually catch the OS and bring it back to Earth and then release it similar to what OREX did. And so these elements are the same, regardless of whether or not we're using a cruise stage and a aeroshell with a parachute, or whether we're using a heavy lander. The trade and the option spaces in our EDL, how we're getting to Mars. By going with a smaller MAV, and so MAV Marshall team with their contractors, their primary partners, their commercial partners, were actually able to reduce the size of the MAV from 450 kilograms to 350 kilograms. That's pretty significant without increasing risk and without increasing their schedule. And so when we talk about where we intend to be, and we're talking about that we're targeting a PDR in a year, a little over a year from now, that team has been able to conceptualize a significantly reduced MAV and mature their design and have confidence that they can get to their PDR in February of next year. That is pretty phenomenal. And that is pretty aggressive. Oh, yes, the scientist is reminding me to tell you that it is still 30 samples. Thanks, Lindsay. I forget that sometimes, how important that is. And so that is our landed platform. And you can see this little gray area is what we call the coffin for the MAV. We were able to simplify the landed platform. If you remember before, it was a propulsive lander, and now it's a three-legged stabilized lander. No longer have the solar arrays, we have RTGs. And one of the things that came out of this, which was pretty exciting, was a different methodology for breaking the chain on the surface of Mars, which allowed us to have confidence that we would have pristine, not only pristine samples, but the OS would be pristine. And so we wouldn't need to utilize a sterilization method for CCRS, which allows us to simplify CCRS. All of this, again, the teams have been working. So while there have been independent teams that have been off looking at this, we made a conscious strategic decision that we would continue the engineering development of the elements that were common to any architecture. And so we are continuing and have been making forward progress on MSR. So we like to call this chart the elephant chart. So it looks like an elephant. And so just want to point out to you, as I was sitting over there, and one of the first things I said to Lindsay when I joined MSR was, MSR isn't a science mission, it's an engineering mission. It was really clear to me that it enables the science, but it's an engineering amazing mission. So I'm bookended by the science, right? The critical part in the middle that's going to bring the samples home. And so this is what this shows. So it shows Mars 2020 launch, and it shows the sample receiving project on the end. And what you see in the middle are the two missions that I talked about. So our current strategy in our plan is to launch ERO with CCRS in 2020 so that they're on station for when SRL arrives. And the two options that you see in the middle is option A, the traditional, with the sky crane, or option B with the heavy lander. And then you can see the common elements. We have a strategy that gives us confidence that we can launch ERO in 2030 and launch SRL in 2031 so that we can get samples back as early as 2035. You guys should be clapping for that. I'm just, that's pretty significant. I also want to talk about something else that's pretty significant. So the analog sample collection opened in November of 2024. We have 5 analog samples that have been collected already. There are additional sites that have been identified, and you see those on the map. I know that there's a talk later this week, on Friday morning. It's going to talk about the library. But if folks are interested in getting samples and requesting samples, please scan this QR code. And then I want to show a video that I find extremely exciting, and I hope you all find it exciting as well. So in my final comments, I'm going to shift gears a little. I sat in the headquarters town hall on Monday, and I was struck by the frustration, the fear, the anxiety, the uncertainty. And I was woken up early in the morning with some thoughts, and it made me reflect on my 30 years here at NASA. And so I wrote it down, and I want to share it with you. And I hope you receive it as I intended you to receive it. And so I said, I know I'm not a scientist, but in some ways, I'm still that 10-year-old little girl that dreamed of working for NASA, that aspired to not only change the world, but to change the way we view the universe, of discovering the unknown while simultaneously rewriting the known. And then I said, side note, Pluto will always be a planet in my book. In my 30 years at NASA as a technologist, so kind of a little PI, right? Engineer, project manager, and now I'm program director for MSR. I've had the opportunity to work on some incredible projects, and reflecting on my career, one thing remains constant. There are always challenges. On ISAT-2, we discovered a fatal design flaw in our $500 million laser altimeter instrument just 3 months before delivery. Charles lived that nightmare with me, which caused the launch to slip 18 months. On Lucy, we faced a once-in-a-lifetime pandemic 5 months before the start of spacecraft INT. And on CCRS, imagine being told that you were going to be paused indefinitely just 6 weeks before your planned Delta PDR. But through every challenge, we found a way forward. We redesigned the lasers, and that mission, originally designed for a 3-year mission life, has been operating for nearly 7 years, collecting data that's not only valuable to the science community, but is also being used by our military. And let me just say this. I delivered that instrument ahead of schedule and $12 million under budget, in spite of the launch slip. As for Lucy, just as I had promised Dr. Hal Levinson, the PI, everyone was kept safe. We never had a COVID incident. We launched the second the launch period opened, and we came in $50 million under budget. And we started INT a week early. With regards to CCRS, in under 6 months, the team redesigned the entire payload, culminating in a successful PDR. And they did that despite knowing that they would have to move on to other projects, some of which were outside of NASA. I share this because, as Kurt said on Monday, there are always challenges. I've seen them, I've lived them, but through it all, the one thing that has allowed us to overcome every obstacle is the people. Our passion, our grit, our innovation, and our determination. Together, collectively, we will get through this, not because it's easy, but because it's hard. Thank you. Up next is Jake, who's going to talk about Moon to Mars.
Hi, could I just get a confirmation that I am coming through on the audio?
Yes.
Okay, great.
Yes, we can hear you.
Thank you. And I just want to thank Danya for those words. That was great to hear. Change sometimes can be scary, but we're all working together on this on many different fronts. So it's good to be part of a good team and a good community. And once again, I apologize. I can't be with you there in person. Again, it's beyond me. I'm unable to be there, but I'm with you in spirit, and I'm with you. Thank you to the SMD folks as well as the LPI technical team who's helping me to patch through. We'll go to the next slide, please. So for those of you who don't know me, I'm Jake Bleacher. I work in the Exploration Systems Development Mission Directorate, and largely my job is to try and work with all of our different stakeholder directorates to understand the research they want to conduct as we think about how to explore space with human beings. So basically focusing beyond low Earth orbit. Mars continues to be the destination that we're looking at in the long term. Number of reasons why. This is kind of why it's of interest to us from human exploration. Well, it's one of our nearest, or is the nearest habitable planetary neighbor we have. It's got the resources that we think we could use to sustain ourselves once we get there. And we really haven't explored that much of it. You all know this. These are probably similar reasons why you all want to continue the science there. But there are commonalities between just straight up human exploration, robotic exploration, and the science that drives both of those. Next slide, please. Now, for some time, we've been thinking about strategies for exploring and sending humans to Mars to explore. We've got a number of studies. I have to note one of my colleagues, Michelle Rucker, who's been our lead Mars architect for a number of years, retired in January. So for those of you who work with us on the exploration side, hopefully you can send some good thoughts to Michelle as she is, as I understand it, enjoying time on her lounger right now. So, but she was great at pulling together the history of the different types of studies we looked at. Some of you may have contributed to some or many of these actually, but each one of these was constrained by different aspects that we were thinking through at that time. Many of them were optimized towards single points that we were solving for. And so we need to take a step back from all of these studies and start to think through, all right, we're going to the moon. We're going to learn about living away from the Earth beyond low Earth orbit with the effort looking forward of heading towards Mars. So how are we doing the Mars part? So we're really trying to iron out that architecture so we can understand what we can accomplish. Next slide, please. So as we work through these studies, the first thing that we've been doing in the exploration side is looking at some decision road mapping. Over the last year and a half or so, we've been working through models to help us understand what are the most critical decisions we need to make for an architecture to Mars. All of them need to be made, and depending on which ones you answer first, you may have a very different architecture. And so what we're trying to understand is which of those decisions have the biggest influence on the rest of the decision network. So what we've done is use that modeling process to come up with what we think are the most important decisions or early decisions to make. Michelle always used to say, this isn't like what color is the handrail on the habitat. That's a decision we'll have to make, but that one can wait for quite some time. There are other key decisions we need to make earlier. Next slide, please. So this is a list of our decisions. Our team conducts a process called the Architecture Concept Review on a yearly basis, where we present and consolidate our analysis work for the year. And we then make that public in something called the Architecture Definition Document. The QR code you're seeing here will take you to different pages within different web pages within the sets of documents we have there. Some of you I know are following through that with us, but what I want to show here for those who aren't is how our decision network is setting up. So a year ago, we released our first set of priority decisions, and I'll note right there in the middle, the blue one is Mars Science Priorities. It was one of our first set of 7 that we considered to be the highest priority decisions that need to be made. So when you look at those 7, they have ripples that go through the potential network of decisions that we would make subsequently that really alter the way the architecture could play out. We need to know what the science is. Why do we want to go to Mars? So that we can enable that by building the right type of architecture. And for those of you who've worked with us, we get in this loop where we'll say, well, we'll ask the science community, what do you want to do? And the science community will ask us, well, what are our constraints from the architecture? We'll go back and forth. So what we have done now is we've set this decision as one of the top 7. We're working with the Science Mission Directorate, and they have put out a request to the national academies to work through this. So some of you in the room may be on that team. If you are, I thank you for your service on that. But we really are trying to make sure we work through a community set of inputs to help us understand where we're going. We expect that to take at least another year. We're not trying to rush that one. And most of these decisions on that first set are taking multiple years for us to settle on. This last year, we released our next set of priority decisions. So they're off there to the right. I'm not going to read through them now to save time. But you can follow the QR code to go find those if you want to dig into those details. Next slide, please. One decision was made over the last analysis cycle year during 2024. This was discussed, the trades were assessed, and we communicated this to NASA management, and a decision was made on this one. This is the Mars surface power decision. A couple different options that we could use, but if we want to envelope what we expect to be the power needs as we start setting up that architecture on the moon, as we start putting infrastructure in place. What we settled on was nuclear fission as the primary surface power generation source. We have that detailed in documentation. Again, follow the QR codes. But we wanted to take this chance that SMD gave us to speak with you all and just communicate what those opportunities or what those decisions look like. This is the first one, but over the next year or so, we should be bringing the science decision on board with the other set of the top priority decisions. Next slide, please. This is my last slide. I just want to, I'll mention this from my perspective, but it's a collaboration with the Science Mission Directorate. Many of you might be familiar with the Lunar Surface Science Workshops. We initiated that set of workshops that has been going on for several years now, and sometimes monthly, but we usually do probably 9 to 10 workshops per year. And that was because in the lunar part of this architecture, we were making decisions. We had to make decisions to move and stay on our timelines. And we wanted input from the community, but we didn't necessarily have the mechanisms in place to do so. So we set up these workshops. Now for Mars, we're envisioning something similar, although the pressure to make those decisions rapidly is not quite as intense. So we have a little bit more time to think through it. So we want to get this workshop set up, again, collaborating with SMD, who's really leading the effort, to start generating opportunities to collect community input that can serve as basically referenceable material for us as we think through how these architecture decisions are made. With that, I'll stop talking, and if Lindsay or Tiffany want to add anything about the Mars Surface Science Workshops, please go ahead. Thank you.
Thank you, Jake.
I'll just add for the, actually, can we go back one chart real quick? I'll just add for the Mars Surface Science Workshops, you can go to this QR code. It'll talk about the process and how we've come to stand these up, a little bit more about what Jake is talking about. And then you can also submit a topic through an email link there. And we will begin periodic topic reviews to determine when we're going to have an MSSW on which topic.
All right, so we have a few minutes for questions. If you have questions, please come up to the microphones. Wait for me to call on you because we will be rotating between rooms and online. State your name and affiliation.
Hi, Isaac Smith, York University. Donia, thank you very much for the presentation. It's nice to have you and very inspiring words. I appreciate all the presentations. You mentioned that 2035 is a potential arrival date of the samples from the Mars sample return. But I also remember in January, our previous administrator mentioned that Congress would have to fund this effectively now, like the funding should have already started to attain that 2035 date. Are we off track for that now? Is 25, is 35 even feasible at this point?
No, we're not off track. The funding that we have in 2025 supports that plan, but 26 becomes extremely critical.
Thank you.
All right, we're gonna go to Waterway 5.
Okay, no affiliation. In the same lines, do you have any knowledge or inkling about planned cuts to the explorations in general by the ignorant politicians?
I'll just say, as we said on the second slide, currently we have the continuing resolution. I think all of us are following the news right now, trying to understand what that's going to look like. And it's going to depend on what the budget gets approved and where we're going forward at this point.
Thank you.
Amanda?
Amanda Hendricks, Planetary Science Institute. Following on to Isaac's question about budget for MSR to get to PDR in February of 26. By the way, I should say thank you all for your presentations. It's informative. But to get to PDR in February of 26, what budget do you need in the FY26 budget?
So to get to PDR in FY25, we currently have the funding that's needed to support
I'm
that.
sorry. I thought maybe I'm getting the time frame mixed up, but what budget do you need in 26 then?
The budget around 2026 is in discussion.
To meet your schedule though?
To meet our schedule is in discussion, and we anticipate as we go through the budget planning process that information will be more readily available. But we're in that planning process now.
Okay, but I guess one of my question is also about the current budget, because I understand that JPL was allocated 300 million in FY25.
Go ahead.
And correct me if I'm wrong, and yet we're seeing all these cuts at JPL to current missions and to the workforce. And it's really impacting our science and our workforce and our missions.
So with all due respect, that seems like a question that's appropriate for JPL.
But
What I can
who
say,
up there is
what
running
I-
the JPL contract?
what I can say with regards to MSR is that we are funding JPL in FY25 for the work that is planned in support of MSR.
All right, we are running out of time, so let's move to the next question.
Yeah, Roger Weens, Purdue University. First, I want to thank you very much for all that you've done and said. Sorry, I can't see your faces. And especially about the technology and the engineering that went into this. I've worked with engineers all my life, first with our nation's first sample return mission, and then putting 2 instruments on the top of the 2 rovers. And it's really important, but I've always pushed the science a lot. And there's one thing that I want to talk about that's not money, but it's engineering constraints, and that is where we pick up the samples. So there's been talk, well, first of all, originally the idea was to go to Midway and rendezvous there. And it was only a couple of years ago that the Perseverance team was suggested that we would have to turn around and go back and sit in Jezero Crater. And that would not allow us to actually go out into the Nowakian terrain. There's a lot of things that I think that I know we would find out there that would be really exciting. And I want to just mention that if we had turned Curiosity rover around, which I'm also on, and started going back 5 years ago, we would have missed the marker band, we would have missed the elemental sulfur, we would have missed a lot of things in this whole area and things to come. And so just, maximizing the science is really important for all of us. And there's 2 constraints that I'm aware of for Midway. One was, and there were several talks last year on this whole topic. One was that Midway is a little bit higher elevation, and the other is to qualify for not having boulders and so on. But the elevation's only about 70 meters difference, and I've been told by the engineers that that really is not significant. That's in the noise. But the other one of qualifying it is sort of a self-fulfilling prophecy. If you don't go there, you won't qualify it. But there is a strategy whereby you could go partway, qualify something nearby, and then go farther. That would be perhaps a little higher elevation, but one could consider that kind of a strategy that would allow us to continue doing exploration in a new part of Mars, which we have never explored before. And so I just want to ask if that could be considered a possibility. We already actually reconnoitered an area on the rim to actually look at that possibility for a landing site. So I just know that this kind of thing can be done. Thanks.
So I'm a little concerned that there may be some echo, so I'm just going to step this way. So I'll say this, I certainly, it is literally my job to make sure that we get as much science from the samples and from the missions and all of that as possible. And that involves, as we all know, everybody who's worked on missions or with missions understands that there's always going to be trade-offs between maximizing this aspect. You can't maximize for everything. And so, when it comes to the operation of Mars 2020, as both an in situ rover, a sample collection rover, and the rover that needs to deliver those samples to the sample retrieval lander, it has to operate all three of those roles. And so, the ultimate decision about when it needs to turn around and start being ready for meeting the sample retrieval lander and what operations it's going to have is one that is going to happen between, a recommendation that will come both from Mars Sample Return Program and the Mars Exploration Program and gets made, at the SMDAA level. And so this is one that we are trying to think about all of the different pieces together and recognize that there's a lot more exciting things that the Mars 2020 team is seeing on the rim right now than I think we were really aware of, even when Jezero was selected. And I think the rim is turning out to be a lot more of an exciting place than we had thought before. And maybe it doesn't have every single thing that would be available to us out at Midway, but we're trying to look across all of these different variables and see what we can do to maximize the science across it all.
Great, thanks. Yeah, please consider it.
Absolutely. Thank you.
We are over time and there's another session in here. So if you can make your question quick, please.
Alfred McEwen, Arizona, and High Rise PI. Question for Tiffany. The Emerald project received a surprise large budget cut just yesterday for FY25. It's in the order of 10% of cost to go without any explanation. Can you tell us what's going on? Why was this cut made? And are other missions being cut?
Given it was just yesterday, I have to refrain from answering the question. I need to understand how that came down to you. I mean, I have some ideas, but I was not aware of anything being promoted just yesterday. So I apologize for my lack of knowledge, and I will have to get back to you.
Thank you.
Thank you.
All right.
Thank you all very much.
Let's thank our NASA headquarters.